Hello, everyone, and thank you for joining us on today's Senza Fili Sparring Partners webinar, Automation at an Inflection Point. Are you ready to go? Our speakers today are Per Kangru, Business Development and Strategy CSO at VIAVI, and Monica Paolini, Principal at Senza Fili. I'm Kendra Chamberlain, and I will be moderating our webinar. In Sparring Partners, we watch our debaters discuss a topic live on video, and we would encourage our audience to participate in the conversation. Please share your comments and questions using the chat and Q&A buttons on the Zoom taskbar. All comments are visible to all participants, so please keep the conversation polite and respectful. And our speakers will do their best to address questions as they come in and as they become relevant to the topics being discussed, so there's no need to hold your questions until the end. All right, with that, I'll hand it over to Monica.
Kendra, thank you so much for the introduction, and Per, thanks for being with us today. Today it's a topic that I've been looking forward to discussing with Sparring Partners for a while, because it has all of a sudden, I would say, in the last few months, there's been a huge amount of interest in automation, and especially, I guess, it's driven by AI. And it used to be that when you talk to vendors or operators, say, yeah, well, automation, it will come, yes, but it's not a top priority. And now it seems like it has become a top priority, and also a hot topic. And so everybody has been, very eager to jump on the bandwagon and talk about it. But there are some people that actually have worked on it for a much longer time to really know. They've been not only able to talk about it, but actually know, and they have experience. And Per is one of them. So I'm delighted to have him to talk about this right now. So let's go with this. But before we get started with the topic, as always, I would like to ask Per to introduce himself, and then we will go with the questions. And as Kendra said, you should just go ahead and ask us all the questions as we go along, because we don't have a Q&A at the end. We just want to hear as we go along through the Sparring Partners. So Per, tell us.
Yes, so
thank you and what you do.
Yes, so my name is Per Kangru. I'm based normally in Sweden, but I work globally, and I work very, very, very closely with the customers, with the overall industry, including standardization. I work in a number of other activities to really see how can we make I would say the telecom space great again. How can we make telecom efficient? How can we make telecom lean and ultimately, I mean, make sure that the operators get a more healthy business out of that. And that's really been a focus for I mean, all of my career for the last 25 years, where I started working on a automated simulation for IUB load testing and functional testing towards RNCs back in the 3G days. And those were obviously very different days at the time in the beginning of 2000, and then the evolution until today. But it's fundamentally the same problem. You want to achieve an endpoint, but you don't want to have a lot of people involved in all of the steps, because simply put, you don't have enough skilled people available. And when you can automate some of these things, you can do it much more efficiently. And you can test, or you can actuate, or you can act on many, many more things. So over the last number of years, I've really looked at these things in many areas. So one of them has been around how do you achieve the right quality? So if you're looking at video quality, if you're looking at voice quality, how are you able to achieve that? What is the means of how you optimize the network? And obviously optimization is as well a process that you can very well automate. And then over the last couple of years, I've been looking at, together with the industry and the ETSI CSM working group for standardization of basically working towards the zero-touch service management environment, and which in other words can basically describe how do we go to a complete dark NOC environment. And that is work where it was actually prefaced with a couple of years of work jointly between a number of industry parties and a coalition, where we looked at what is needed here, what is needed both from technology development, technology leverage from from other industries and other parts of the world. And then throughout that work, we concluded that we would be going to ETSI and asking for a new ISG to open up. And this was a set of operators that was driving this together with a set of vendors. So VIAVI was one of these parties, and we were a founding member of the ETSI ISG for CSM, together with all of the large scale operators in the world, together with many of the most important equipment vendors. So this has really been my last couple of years, and then looking to see how we, from a VIAVI point of view, can then work inside this ecosystem in various ways, and building up appropriate capabilities, both organically, and then as well helping with some acquisitions where we brought on board some more further capabilities that's been developed. That's been my background.
And it's sort of very interesting and development path. And this is because when you think about the wireless industry, we always talk about how much better we are in terms of performance, and that's certainly true. We've been improving performance in ways that are almost unthinkable 20 years ago, like, oh my God. However, I don't think that we have been as good as making our networks efficient. And I guess it's a trade-off to some extent, but I think that now we're at a point where we understand that we can make our networks more efficient without sacrificing performance. And that is something that I think it's relatively new. Not that we didn't know what efficiency was before, but it was not as important as it is now. Because, first of all, because we can, and also because there are things like energy efficiency that become more prominent. And so, so we need to, that's sort of I think good news in terms of making our networks, again, more efficient, and automation is obviously crucial to that. Now,
let me just add. So I normally say it's not a problem to build a network that is cheap. It's not a problem to build a network that is efficient. It's not a problem to build a network that is having high capacity or is secure. The problem is to do all of them at the same time. And that's where you really get into the sort of the challenge. Can you actually achieve this? And can you achieve it meeting your business objectives? Because the business objectives of one operator is very different from another one. They have different demographics as the customers. They have different amount of end consumers. They have business customers, etc. And that all translates into, different opinions about what is quality. And I think that, all of us travel a fair bit. So we've been experiencing the quality of networks in UK versus US versus Germany versus, say, some of the networks in Scandinavia. And even the best network in some of these countries would actually not be on par with the worst network in some of the other countries. But inside, for example, UK, you would have operators winning this service quality awards and capacity and so on, but at levels where they in other countries would hardly be on the top 3 list. So it's important to understand that we're not even speaking about something that is a regional or global agreement, but it's really local on what you achieve and what you have to compete with and what you have to be good at. So it's not even that you can take best practices or things from all over the world and just apply locally, but you really have to do it intelligently in that sense.
Absolutely, and as you say, it's not hard to do anything individually. You can get a cheap network, but it doesn't necessarily make it efficient. The real challenge is to look at the trade-offs. And the trade-offs that make sense for you. Anyway, within a network, different places, a rural area and the metro area is completely different. So it's to understand the subtlety, which is what we're going to be talking about today. But before we get into the kind of deeper down, you would say, well, automation, well, we know what automation is, but do we? So maybe you can tell us, what is that you mean by automation, or what is that automation is in wireless networks?
Okay, so automation here is so if you just look not only on wireless networks, but if you look in general, so automation is obviously that we we want to achieve something, and rather than having a set of humans doing, 10 different steps manually, we try to automate the execution of those 10 different steps. And the key to that discussion is obviously being able to know, when should I execute this? When should I start with executing a certain step? Being it energy efficiency, where I'm saying, I'm now going to switch on energy efficiency. I'm going to switch on a MIMO sleep mode for this particular cell for a particular period of time. How do I know that that is supposed to be the right time? Can I use a single triggering point to do that? Is there a single FM or PM message that I can use to basically start that off? Or do I need more of an AI-driven forecasting algorithm that allows me to say that at this point I'm going to start this sort of automation process or automation activity, and then for how long should I basically manage this specific network state? So when we're looking at this automation, there are areas where we need very complex forecasting models or AI-driven decisions to basically say, now is the right time to do this automation. In other areas, we're really speaking about something simple. A trigger point can be a trigger point from a customer care portal. Someone logs into customer care portal, basically it says, I feel that I have an issue here. And then the system would automatically go through a number of automated steps to validate whether this customer actually has some issues, maybe perform some automated connectivity test, maybe some automated speed test, etc. And those are things where when you start looking at it, I'm just going to give one example here of how we worked with Openreach in the UK to actually help to manage this. So Openreach is a wholesale provider, so they don't sell directly to any consumers, but they do a B2B service with people who deliver that end service to the customers. And they had a huge problem with that. Whenever someone was basically complaining that the internet connection didn't work to their basically service provider, then they would automatically flag that as, oh, it's going to be an Openreach service issue on basically the connectivity side. So Openreach had to put a man in a van, travel out to the location, bring out some equipment, measure whether this would be a fault or not. And interesting enough, from a statistical point of view, they came back with that in about 70% of the cases, there was no fault found. There was nothing. So here, there's been a man in a van going out, doing this testing, coming back, writing a report saying no fault found. And there was a whole lot of time wasted, a lot of cost wasted. And obviously, if we now speak about environmental things, a lot of energy wasted in that van traveling out, potentially hours driving to the site. And we were able to put in place a automation model for this. So that same thing is basically validated within 5 minutes, fully automated, and we come back with an outcome, whether there is actually a physical fault or not. And if there's a physical fault, well, then at that point we are able to fundamentally go out and see where we are, where we're good and bad, and actually address that. So based upon this, we're able to simplify a business process. We're able to increase customer quality, because instead of waiting a week to basically be told there's no fault found, we're able to do that within 5 minutes. So the automation in this case serves basically two needs. One of them is that we can get much quicker mean time to repair and mean time to resolve. We're able to save a lot of energy. And based upon this, we're able to drive a lot of value. And you can actually go on YouTube and find Openreach publicly talking about this and how it's practically saving them several thousand of truck rolls on a weekly basis. So that's an example of an automation project which is extremely successful, both from a business point of view, a customer quality point of view, and then as well from an environmental point of view. So simple one, solves a simple problem, but does it extremely efficiently, and then achieves a very radical outcome. So these are the type of automation projects where you may look at it originally and say, well, it's actually a pretty okay process today. And from an Openreach point of view, they had a mean of actually reclaiming the cost for this back into the service provider when they logged a trouble ticket that wasn't broken. Now we're able to do this much more efficiently for everyone in the ecosystem. So automation at its best serves both sort of efficiency gains immediately for, I mean, the specific task at hand, but it delivers more value to the ecosystem because you can do more better services, you can improve customer quality, etc., way beyond what you could originally. So, and I think this is, if you look at the RON environment, I think there's a sort of a starting point for RON automation coming now in various ways.
Yeah, absolutely. And I guess that, you know, one thing is that when you look at the results of automation, you say, oh my God, this is such a big improvement. But I guess that the difficulty is at the beginning for an operator is to jump, you know, because you're always, when you introduce automation, there is always a question, is it going to work or not? You know, so you need to kind of have a leap of faith in a way. You need to get into it. And I think that that's where a lot of operators are kind of
Yes.
right now. They are ready to jump, but they haven't jumped, or they just did the very first small jump. And this is why, you know, the title of the Sparring Partners today is about the inflection point. And we talked about it, and actually, since we got the title, we got even more convinced that we are at an inflection point, because, you know, as I said, there's a lot more interest, but there's a lot of more activity also going on. So maybe you can tell us, and then we can then go back into how you get into the automation. But why do you feel like we're in an inflection point?
So inflection point is, this is a dangerous topic because humans always feel that we live in the best of all times, and this is when things happen and when major things take place. But we obviously need to look quite objectively at it at this point. So the inflection points we're seeing here is basically both technical, they are commercial, and they are as well, I would say, societal. So in this case, many automation projects historically have been a matter of, if I automate this, I actually need to lay off people to get the value out of it. And if you look at, especially incumbents in Europe, it's been very challenging from a labor point of view to lay off people because of trade unions and workers' council, etc., objecting that. And basically protecting their members so that they wouldn't lose their jobs. So what's happening now is that if you look at, and this was one of these things that brought about exactly this ETSI ISG for Zero Touch, most of the incumbents today in operations have an aging workforce. This aging workforce is actually going to retire in the next couple of years. And when you then look at sort of fundamentals of, is the operators able to attract smart young people coming out of the best schools? And the short answer is no, they're not. This has been acknowledged by the Deutsche Telecoms of the world, the Vodafones of the world, Telefonicas of the world. So what they're seeing is that they have a window right now for a couple of years where they have to solve this problem. And ultimately, it's two options. Either they fully rely on outsourcing to some part of the world where there is availability of staff, or they find a way to automate. And now at this point, the Workers' Council and trade unions and so on are fully on board because they know as well that they can't add more people because you can't hire them. So from a societal point of view, now is the point where these operators can actually go and automate, and they can implement it. They don't have to have an issue by having to lay off thousands of people, in this case, for operations. Yes, I think we've seen redundancies in other areas of the world where people introduce chatbots and so on, which I think has been the first sort of move of automation, where there've been customer care teams that been sort of laid off and made redundant. But when we speak about operations teams, it's now at a point where this can actually happen. And if you then think about from a technology point, what is it now that enables this from a technological point of view? Well, a lot of the network components have now been evolving so that they actually contain the right set of APIs. And with the right set of APIs, we can actually start doing a lot of this automation. The next really critical components to this automation story is that you have to know what you have out there in the network. So you have to have the proper ability for inventory, proper ability to stitch that together as a topology. And when you start looking at that problem, there's been innovations in the last couple of years in graph databases, and how those graph databases can really help to provide a solid working foundation for an inventory that gives you topology. And with that stitching together, you can actually then see both how an AI engine can effectively stitch together and identify when and where you have a problem. That's actually at the point when you can start doing the automation. And if you don't know what you have out in the network, it's very dangerous to go out and start saying, well, I'm going to change this microwave link and the configuration of that, because you may not know what are other services running on top of that. And you may actually cause a disastrous outage for certain parts of your network, even if the fix what you're trying to implement was perfectly fine for the problem you saw. But if you don't see the big scale of what you're trying to achieve, it's very, very dangerous. So then we really get back to the last point, which is how to build trust. How to build trust that these systems will properly function. And this is once again where we have now a window of opportunity. So you have humans in the loop automation, where you start off with, I'm going to do this. The human know that this is the steps I would normally take. You build an automation environment for that, and then you present for the human what has the engine decided that is going to be the next steps. The human looks at this and says, yeah, this looks reasonable, agrees to this automation. The automation is running. You're able to validate and see that, yes, this automation took the right actions, came back with the right output, and the network, there may have been a service degradation, there may have been other things. You see how that is now being alleviated, and you're back into, good operations. So when you're able to then see this loop where the human in the beginning is in control, is able to push the button and say, no, this didn't go well, I need to do a rollback. At that point, you start to build trust. The less times you have to hit that button rollback, the more trust you build in the system. When you hit the button rollback, then obviously you have to go back to the drawing board and say, why didn't this automation script or this automation ability deliver the right outcome? What did it do wrong? Was it an AI-based recommendation? Well, maybe I didn't train it well enough. Maybe I need to retrain it in some aspects. If it was instead of just of an AI-based model, I basically took a trigger from something, then decided to execute a set of steps and then do it. Say, for example, I think most of us who's been in the RON space for a while know that we have sleepy cells. So sleepy cell detection has been one of these things when we speak to the RON vendors, they knew about it in 2G, they knew about it in 3G, they knew about it in 4G, and we have it in 5G. But in all of these technologies, in every transition, they always tell us, oh, we solved the problem now. We're never going to have sleepy cells again. But ultimately, they do show up. And equipment, is not foolproof. So this is a good example of where something, once you decide that you have a sleepy cell, you're going to run a specific activity to then just recover from that. And if you then have a single trigger saying this is a sleepy cell, and then you go through and validate, a couple of stuff, and then you do a reboot of that or a reinitialization of the cell or whatever is the right procedure for that RON vendor. That's one of those things where the more, call it a direct single trigger drives an automation. And once you build confidence in that, you can actually execute that, fully automated. So step by step, you're building confidence. That as that confidence grows, you're able to automate more and more things. And the human can then step by step look at what are the problems that I have not yet solved. Because the beauty, or the scary thing, depending on your perspective on it, is that we're never going to run out of problems to solve in the mobile networks or any network. So we're used to looking at these KPIs and saying that, I have a call success rate of 97% or 99% or whatever it is. When you then start breaking down, what is it that is actually broken? You get a really long tail of stuff that you could deal with. Most of them is never dealt with today. So automation is then going to basically free up resources on starting looking at those things and what can actually be fixed that is today not at all being addressed.
And going back to the fact that we have trouble finding people, the more automation you have, the more interesting the job is for humans. So,
Yes.
you still need humans. As you said, we're never going to run out of problems. We're still going to need somebody to decide what to do in some cases. It's not just the network will not just start running itself without us taking a role. But this might make telecoms more attractive to people, because instead of having to go and fix the problem manually, you can actually think of something more strategically at a higher level. But
let me just add. So this is where we can learn of the rest of the industry. So we can learn of how has the hyperscalers done this? How have the large OTT companies done this? Because they're running a similar type of automated environment. So this is where you both have the DevOps role and you have as well the SRE role. So those roles is basically becoming sort of new roles for the telcos, where instead of being a NOC engineer, you become a DevOps engineer or potentially an SRE engineer for the platform. So this is how the role is evolving. So my estimation is that most of the operators will be able to go down to somewhere 15 to 20 to 30% of the current staff, based upon that you're upskilling a set of team members to become an SRE or to become a DevOps engineer. And then based upon that, they are basically transitioned to quite different role. But as you say, you obviously need the people, but we can look at what is the hyperscaler role definitions for DevOps and SRE, and really look at what type of skills and capabilities do we need. Obviously, they need still the telco domain expertise, so that they can run a 5G network or they can run other things, and it's not the same as just running a set of Kubernetes clusters in a sort of hyperscaler environment for business application.
Absolutely. So and that basically changes the way the sort of the internal structure of the team, the way everything works. So it's not just you add some software for automation. The change goes deeper than that.
Yes,
because you need
absolutely.
to change all that.
And I think the key sort of soul searching the operators needs to do is down to where do they put the business focus? What do they want to be best in the world in? So if you look at mobile operators today or telecom operators today, they're really best in the world in sourcing equipment and operating that equipment. But they don't build it. They don't design it generally. But they're really good at sourcing it, and they're really good at operating it. If you now look at hyperscaler, they are generally really good at building stuff and then operating it because they built it. But they generally don't have a normal sourcing team similar to a telco, where you go out and work with the Ericssons or the Nokias of the world and basically source from them. Instead, they're buying components of infrastructure that they stitch together. They build their own software stacks and they put them together. We've seen all of the large-scale open source projects. There's been offshoots from the Googles and the Meta and the Twitter of the world, etc. Those open source projects is obviously examples of how these companies have thousands of engineers internally. On the telco side, we've seen some operators turning into this. We've seen some operators hiring thousands of R&D engineers, software engineers, that's actually going to develop stuff for them. So they are turning from a soul searching point of view to be really good at development of these type of services, infrastructures, platforms, etc. Whereas other operators instead is looking at, can I actually find the right partners? Can I actually then do the right sourcing of this infrastructure, of the capabilities that allow me to operate? And that difference between operators I think will be seen going forward. It's not obvious for me which of them is going to be, best outcomes, but we're seeing very, very different strategies between operators that I said hires thousands of new software engineers versus operators who goes out and makes significant multi-billion-dollar commitments for vendors on platforms and technologies.
Yeah, I guess that one way to look at it is that it's a way to differentiate. So, different operators and everybody in the ecosystem is going to differentiate in a different way, which brings me to the question of you guys, VIAVI, what is your approach? Because again, everybody's talking about automation, But
Yep.
what makes a difference? What is your take on it?
Very good question. So historically we're most well known for having, I mean, really good, I would say, solutions that provide data. This might have been our RON monitoring solution that is providing really good intelligence around what's happening in the radio access. We're covering, I mean, huge amount of networks for that. We're covering order of magnitude 1 billion of the world's subscribers that is basically monitored by that solution across different parts of the world. That has been an extremely valuable data source for people doing RON engineering, RON optimization, and so on and so forth. So that's one starting point. Then we have other solutions that are monitoring the core networks, monitoring enterprise networks. We are actively, for example, testing and validating front-haul, backhaul connections through techniques like TWAMP and other things to basically make sure that you have the right latency and right performance on those things. And we as well have optical fiber monitoring, which can then make sure that optical fibers are both working well, and then as well, if someone tries to intercept and do eavesdropping on them, we can detect that. So that's been our historic foundation, which really means that we provide data up to intelligent people that is able to use that data to very efficiently operate the networks. So that's been our cornerstones for many years. We've been working with many of the world's operators to deploy this, and it's really been fantastic. But then, as we're moving into the automation angle, what we brought in since about 2 years now is a component of discovery, inventory, and topology. And since we can do that, we can then stitch together how does end-to-end network look. And it's important to look at this, and in order to automate here, we really need to understand how it's end-to-end, both from a sort of horizontal perspective, from a base station with an antenna all the way out to the service on the other end. But then at the same time, it's really a inventory and topology on the vertical side. So from what I mean with that is that if now operates, for example, a 5G core inside a Kubernetes cluster, that Kubernetes cluster sits then on some sort of infrastructure, like hardware infrastructure, that consists of CPUs and hard disks and power supplies and so on. And this sits in a rack sitting inside a data center, which is then having certain interconnectivity, etc. Now you're getting the vertical slice of this topology. Because if this service, 5G core network, maybe underperforms, is it because of the CNF in itself, or is it starved for resources either on the Kubernetes layer or on the infrastructure layer? Or would there potentially be a case of it's a broken hard disk, or the AC that is cooling this data center is underperforming, so the whole data center is heating up, and that is basically causing issues to basically this server, that cause issues to the Kubernetes, to the CNF, etc. So looking at all of these things horizontally and vertically in the full slice, independent of whether it is, as I said, now a CNF sitting in a data center, could sit obviously in a hyperscaler, but as well where you have, say, a front haul service for a 5G and O-RAN network, for example, that runs on top of a IP layer. That IP layer sits on top of some wavelength. That wavelength goes on a physical fiber. That fiber sits in a cable of fibers, and that cable of fiber sits in a duct. Now you start to look at things that what happens if someone cuts that duct with some construction equipment? Are you now able to recover that automatically? Well, you need to understand, do I have an alternative wavelength available in some other physical duct, etc.? Or could I reroute this using some microwave link, or as some of these radio access networks do, they can do some self-hauling on some of the available capacity. So looking at the problem of automation is really one of, you need to understand how the network stitches together, both the actual current path, alternative paths, and then looking at that when you start overloading it with performance data, fault data, data we pick up from all of the other intelligence sources that we have, which could be the probes, which could be other things. This is where we now start to get an AI ops engine that is really looking at all of this data and then making automated recommendations. These can be automated recommendations that can be instantiated, immediately. So you can actually recover from a fault immediately. Or it can as well be a case of that we're making more long-term recommendations in means of this part of the network is running out of capacity. We're forecasting for the next 2 months. So in 2 months, we recommend that you're adding some further carrier into this site. Since we are in this case as well looking at, for example, revenue data coming into this, we can actually generate an automated business case and return of investment calculation for that specific site upgrade. We can as well identify when there is a need for optimization activities, which can then be automatically targeted to optimization teams, etc., where we then validate did that optimization activity actually return back with the anticipated output. So we're driving a fully learning process with then the reinforcement learning into that AI model. So we went from being data sources, which are used by humans to achieve an outcome, to now getting to a point where we are able to then drive automated outcomes based upon an intent being put upon us on what basically operator want to achieve. Next evolution of that is obviously looking at how you turn this capability, rather than having it as a sort of analytics engine and an AI ops engine, it as well becomes available, I would say, as a sort of digital twin model that you can then run various other activities around. We demonstrated some of that at TM Forum in Copenhagen earlier this year, where we used and looked at how we can automate some business interactions for B2B services to basically co-locate servers. Could be from a hyperscaler, it could be an edge device that needs to be co-located close to an enterprise service. How you're then using a digital twin of a data center to be able to identify available capacity, available energy, and available cooling, and then automatically being able to do placement decisions on, for example, these edge services in those environments. So I would say we moved from being a fantastic set of data sources to actually becoming a provider of fully automated solutions leading up to basically the dark NOC. And this covering literally all domains from radio access all the way out to cloud and the hyperscaler space. So we've taken on a pretty big chunk of things to basically deliver, but we're seeing that both with these inflection points, which means that customers are ready. We see that the industry is ready, the technology is there, and then these inflection points, that means that people actually have the compelling event to go and do this. So that's where we're in the market and what we're aiming to deliver now and going forward. And obviously, we're not alone in this, but working with a lot of fantastic partners to deliver on this.
Absolutely, and I think that networks are getting more complex. They're getting more disaggregated, so you have more players. So being able to work with a lot of companies, a lot of players in the ecosystem is crucial. But also, as you say, you kind of need to get started from sort of the basics. Topology. You need to know your network. You need to know what services you provide in order to automate on top and to build what you've been talking a lot about trust, about because when you get into automation, there is obviously the sort of the fear, the worry is that you get into a little bit of a black box situation where obviously what you used to have complete control over, so there'll be a person doing something, you don't have that anymore. So you have to trust the solution. So you need to trust that you have the first components, your good knowledge of your network at the right detail, at the right time, and then you're able to use that information in a good way. So, that's so. Let's now talk about, you guys have been working with operators for a long time. So can you tell us a little bit about what kind of issues are they, seeing in terms of what are the challenges that they're facing, and why, you could say, well, they're ready to deploy and to automate, but what is that is sort of like sort of holding them back? I mean, what are the reasons why some of them are not there yet, or what is that? What are the challenges they're facing now to move forward with automation?
Okay, good. So this is actually a question which you can answer, or you can look at in both the something small and something very specific, or something that is on the more bigger horizon of things. So let me take an example of an old friend and an industry colleague here that last summer he was running a medium-sized European network, basically transmission network and IP connectivity. And as we know, last year energy prices went up a factor 10 because of the Russian invasion of Ukraine and what that caused for natural gas and other things. So that 10x energy bill really meant that his legacy routing and switching equipment became terribly expensive to operate. Before that, he had no urgency to remove it. But now, with this, he had a real urgency to remove it, and he could replace it with something that was much smaller, much more efficient, and basically doing this. He ran a quite, small, medium-sized network, and based upon that, he was able to very efficiently make this decision and rip out the equipment, replace it, and actually save that energy and directly to his business, make sure that his bottom line was not directly severely impacted of this 10x increase of energy cost. So in a larger operator, on the other hand, the question is going to be, how can you make that decision? And how quickly can you react? And if you then have full understanding of inventory, you have full understanding of energy utilization, and you have good understanding of then what is the effort and cost to actually go and do the site work to replace these things, then you can automate the business outcome recommendation on these are the things we should replace in this period of time, and you would be able to actually come up with that recommendation within literally, half a day and generate that, rather than someone manually sitting and going through a set of equipment, Excel list of equipment, trying to figure out, is it actually still in place? How much energy is it actually consuming? Trying to calculate whether it makes sense or not. What are the services operating on top of it? Can I actually do this, etc., etc. So those are things of where the compelling event is that energy prices went up a enormous amount, and I need to take some immediate action if I don't going to have this really hit my bottom line. So there's many smaller things like this that is driving a need for automation. And obviously, once you start using these things and you start realizing that you don't have to work extreme long hours for many weeks to get to this outcome, but you're actually getting it in literally, hours instead. Then at that point, you start to build trust and obviously happiness across the capability of the system. The next part of that is then looking at, more I would say, complex things. So I think all of us have been involved to some extent in, if you've been in the radio environment for a number of years, you've been involved in the CSON space. So in CSON, we have had a number of automation capabilities to do various recommendations. So we've had a capability to do capacity and coverage optimization. We've had ability to do find PCI collisions. We've been able to do a number of other tasks automated. But those CSON platforms have historically been sort of quite single vendor ones. So you take the data from your infrastructure, you feed it into one of these CSON platforms, and then that vendor probably have 2, 3, 4, 5, 10 different applications sitting on top of it. But that's been very challenging when you're then saying, well, I really have more needs, and I actually see this nice thing happening out there by someone else, and it's really challenging then to bring it on board, both from a cost point of view, integration point of view, and so on. Because how do you validate that that app from someone else could actually work on this data feed and so on? How much effort does it take to build that understanding and trust and so on in both the platform and the capabilities? And this is where now, if now speak about inflection points again, the evolution, which started in O-RAN, but is now actually coming into 3GPP, which is that we're going to have some sort of platform. We can call it a RIC, we can call it an SMO, we can call it something else, which is then giving you a independent platform capability where you then can run these apps in, calling it R apps or X apps, and how that is allowing you to then normalize the data access, normalize how you are actuating on it. Because one of the things before is, do you trust this app to go out and make changes to your live network in potentially 10,000 cells or 100,000 cells or even more cells if you have a bigger network? Or would you be somewhat scared if you're going to take an automated action covering 10,000 cells in your network? Well, most people would be a little bit concerned if you're going to take that with a new app that they haven't run before. So in this O-RAN ecosystem, or well, call it instead Open RAN, or call it the evolution of the RAN management area with RIC and SMO, we're seeing a lot more capabilities for this. So one of the things that we in VIAVI is doing is that we're bringing out and we've been working with all of the plugfest activities for O-RAN Alliance, and we've been working with a number of vendors where we bring out a RIC tester, which completely surrounds RIC, generates traffic according to relevant configurations you set up. You can set up and build any network you want, and with any sort of user and environment you want. And that is then generating this traffic in a closed loop manner. So the app sitting inside the RIC receives the data, being it from the E2 interface in the RIC environment, or R1 in the sort of SMO environment, and then the app can act on this. And the acting of the app is then actuated through the RIC into our simulator. We make the changes that has been proposed, and the simulation continues. Based on this, we will immediately see, did this app crash the whole network, or did the app actually generate the energy savings that was anticipated? So in this way, you can both build the trust that the app is performing functionally what it should do, and then you can start benchmarking. Does it perform this in a better and better way over time? So if you look at, if you now think about a CI/CD cycle, you don't only want to enter the app at the beginning of this cycle, but you want to maintain this trust over the lifetime of the solution. So this is where we then integrate into fully automated CI/CD cycles that allow you to not only develop the app, you're allowed to maintain it and manage it over time. And if that is an app from VIAVI, or if it is an app from anyone else in the ecosystem, that doesn't matter. So that allows you to bring trust and validation and actually testing real traffic environments inside the lab for these very, very complex changes. Next part of that discussion is then going to be, once we go out in the live network, how do you now assure that when I'm going to do that change, that's going to be done to 100,000 cells, that stuff doesn't really go bad? And that is where you will test this against, and now I'm talking a little bit about our sort of future thinking, but it's testing it against a sort of network guardian model, where that network guardian model will look at what is impact of, for example, two apps want to change the same parameters, and what will be the conflict mitigation between those two. How do you resolve that? The two apps want to change the same parameter with different values. What happens? We can then validate that, which is basically done by the same type of engine, but from a sort of digital twin technology of the live network. We can as well validate and see, are these other changes, regardless whether they're conflicting or not, will they actually make the network better as the app suggests, or will it potentially lead to disastrous outcomes? And I think the best analogy to this and how we build trust is to look at some of the large-scale network issues we've seen in the world based on BGP failures. So the last one of this, I believe, was related to an Australian operator that received some BGP updates from their parent company, and that actually shut off, or well, it triggered a bunch of sort of security aspects where they had automated actions against potentially security threats, and that inadvertently switched off a large part of their network and data access for the customers. So in this case, that was a large-scale BGP issue. A similar thing is what brought Facebook offline. I believe it was in 2018, which was then an inadvertent BGP update which caused those large-scale outage. If you would have validated those against this type of network guardian, you would have seen that, well, this would have been the behavior, and you would have been able to capture this type of update before it was sent out on the network, and then being able to sort of mitigate these type of outages. So once again, building trust by building in ability to validate and control, and then as well, you simulate in the CI/CD process, but you make sure that it works in real life against this type of validation capability before you activate sort of dangerous large scale configuration changes.
Yeah, and it's actually interesting that the moment you start talking about trust now, you've also just started to talk about Open RAN. And
yes.
the whole, we just did a Sparring Partners last week on Rick, and Rick is going to be a massive, well, a very important part of Open RAN, but also potentially a massive headache in the sense that there is so much that we need to make sure it works there, because there is so many things that are interacting. So you're adding a lot of different moving parts. You need to make sure everything works together. So it's not just interoperability between CU and DU. We just get into a whole different area. And actually that brings to mind the recent announcement of AT&T. And how do you see that fit into this whole discussion we're having of the inflection point? That seems like it's part of the inflection point, isn't it?
Yes. So what we see from this AT&T message is that first of all, they're doing something very unique. And I discussed this before when I said that there will be two groups of operators that decide that they will maintain their expertise in sourcing and operations, and actually select the right partners to work with. So in this case, AT&T have re-emphasized the need. I mean, their commitment in Ericsson in this case for basically delivering these capabilities. So going almost single vendor in what has traditionally always been a multi-vendor scenario. That obviously simplifies automation, but you have to have an enormous trust in this vendor. So this trust then comes into the automation platform. So as part of this activity and as part of the announcement, you can see it both from Ericsson and from AT&T. It includes the Ericsson intelligent automation platform, and that's a platform that we in VIAVI is well versed with. We've been working with this one for quite some years. We've been part of their public launch of that platform, and in this case, we've been part of that with our geolocation capabilities. So this is a geolocation capability that I spoke about before that has been ambiently available for many operators, but where it's been used by traditionally feeding into run engineering teams and so on. What we've done in this case is that we have containerized the geolocator, made sure that it's available as an R app, and this is now not only available for feeding into VIAVI R apps or VIAVI apps sitting in this, but it's really a foundational capability that is then available for any and other apps sitting on top of this. So if you take a look at, for example, CCO applications, or we take a look at energy efficiency or anomaly detection apps, many of them, based upon the other PM and FM data they are receiving, they're trying to sort of second guess what is approximately the locations of the users, which takes computational effort. In this case, we disaggregate the system. VIAVI calculates geolocation, provides this data to the other applications, and they are then able to run their process much more efficient because they get the actual geolocation of the users. They don't have to run their own processing for this, put their own algorithms to basically achieve that approximate location. It saves them compute, gives them better accuracy, which then leads to better outcomes in their recommendations and decisions. And from a VIAVI point of view, we can then spend our energy in making sure that we have the best geolocator, making sure that that is then available to each and everyone in the industry that want to use it. Now, this I would say with AT&T might be the first very large-scale environment where you start to see this ecosystem of apps not only working on a sort of horizontal layer, but actually potentially working together with each other to build up a very strong overall capability. So it's very positive to see this announcement and the move, and I predict that it's not the last one, but it's going to be a couple of other operators following in the same footsteps of AT&T here over time, whether they will go single vendor or whether they will go instead and say, I want to have a independent platform that's going to work fully multi-vendor. I mean, that's up to each vendor, each operator strategy, but it's really talking about the foundational model of moving into a platform approach, and then in that platform approach, being able to have freedom to add and manage applications on top of that you either develop yourself, you get from a large scale of the ecosystem, etc.
Yeah, and I think that the increased flexibility that we see in the RAN is just going to be a great opportunity to explore different paths. Now, if you as we talked before, every operator has his own different needs and will go at his own different pace and so on and so forth. However, you've been working with operators for a long time. What is your advice in terms of moving forward with automation? How aggressive should they be? Where is it they should go first? I mean, they're not going to have everything 100% automated on day one. There's not one single path, but is there something that we can extrapolate and distill in terms of advice that you would give to operators?
So first of all, every operator has some level of automation today already. In some ways, it's either engineers themselves that figured out that certain things can be automated, and they have their own Perl scripts and Python scripts and whatever that they are using to basically drive various sort of mundane tasks that they do. So that's one thing which is already practically happening, and then operators have, as I said before, CSON applications and so on, which is already doing automation. So if you now start looking and thinking through what would be the next steps, and I dare to say that right now technology is not the limiting factor. Technology from us and competence and capabilities from VIAVI and potentially other players in the industry, that is not the limiting factor. The limiting factor is going to be organizational ability for change. So we can work with any operator that has that capability in that team and that organization. So when we're working with some of the greenfield operators, they start every day by saying everything will be automated from immediate. I will never ever have a manual process, and I will make sure it's automated immediately. Those are very easy to work with because they don't have any legacy. They don't have to drive a change. So with them, we can literally look at anything and all over the place. Other operators which sits with a huge set of legacy processes, they may have areas of the business that is outsourced today. They may have areas of the business which is done in different ways. Then let's look at the part of the business where you are actually under control. And where you're under control, then let's look at how we can help you achieve something that is today a burning problem. And what we've seen in many cases, especially today with today's cost of capital and interest rates gone up, is that a lot of people are very interested in seeing, is there an ability to do smart CapEx? Can I be getting better return for the CapEx I'm spending, and can actually spend less CapEx? So we've been working with a set of operators to look at can we really, for this period of time now, give them intelligent advice on this. And I think the best example we have is an operator in Southeast Asia, where we were able to look at their RON spending and give them very intelligent recommendations based upon that. And their outcome was that they saved more than $20 million of CapEx for the first year. And in this case, it was a matter of understanding where in the network did they have already available a massive amount of capacity that was never utilized. And then in other areas, figuring out where they actually had capacity crunches, and then being able to help them add capacity in those. When they historically been working with other means, so with equipment vendor recommendations and other things, they've been sort of getting general recommendations of blanket build outs and so on, which led to massive over deployment in many areas. So our recommendations was fully down to this is how you can, I mean, really get there. So what we automated was basically the business decisions of where do you spend your CapEx. That was a process that operator could actually take immediate action on. And obviously, every dollar you don't spend at that point becomes, I mean, a saved dollar. So $20 million impact to bottom line, which I can say gave a immediate return of investment significantly less than a year. So in this case, it was a fantastic project that we delivered, and it's a type of values and deliveries we can do in the industry. So if that is right thing for another operator, I don't know, but it's key to look at something that is actionable, something where they can immediately drive the change and realize the value. As in any other change management, you start with something that can drive the success. Next step is then that you do the things that are a little bit harder, requires a little bit more organizational work, and then step by step you get to sort of more or less full automation. But you have to start somewhere, and you want to start with a success.
Yes, and I guess you need to start with good knowledge about what was on in your network, what is that you're looking forward, and then move accordingly. We're at the top of the hour. It's been absolutely fascinating talking to you, and I'm sure there's much more that we can be talking about, but we need to keep going. So thank you so much, and thank you all in the audience for participating.
Thank you very much.
And Kendra, back over to you.
Okay, great. Well, thank you again to our speakers, and thanks to the audience members for today's session. A recorded version of our webinar will be available at senzafili.com in the coming days, so check for it there. Thanks again, and we look forward to seeing you at future events.